If we write this, it is obvious that we find x by taking the square root of 121. But what if the exponent is unknown? The unknown value of the exponent is called the logarithm. In this example, the logarithm of 8 to base 2. We write it like this. In general, the solution of the equation a to the power of x equals c is called the logarithm of c to base a. Remember that the logarithm is the value of the exponent that you are looking for. Note that no value of x satisfies the equation a to the power of x equals 0. This implies that we must clarify in which cases the logarithm is undefined. The term from which the logarithm is taken must be greater than 0. For example, the domain of this function is defined by x minus 3 greater than 0 and therefore x greater than 3. The logarithm to base 10 is very common. Therefore it has its own notation. It is known as the decadic or decimal logarithm or simply the common logarithm. Another special case is the logarithm to base e. The irrational number e is named after the Swiss mathematician Leonhard Euler and its value lies close to 2.71828. This logarithm is called the natural logarithm and also has its own notation. The natural logarithm plays an important role in growth and decay processes as they occur in nature, for instance bacterial growth and radioactive decay. Now let's take a look at some logarithmic calculations. Dividing logarithms which have the same base changes the base of the logarithm. The logarithm of a divided by the logarithm of b equals the logarithm of a to base b. If your pocket calculator or calculator app only knows decadic and natural logarithms, you can use this transformation formula to calculate the logarithm to any base. In essence, the calculation rules do not deviate from the exponential calculation rules. Remember that logarithms represent the flip side of exponential calculation, so to say. An important rule makes it possible to transform exponents into factors, which will be of use when solving exponential equations. The logarithm of a to the power of b equals b times the logarithm of a. This is equally valid when the exponent is a quotient. The logarithm of a product is easy to determine with the product rule. The logarithm of a times b equals the logarithm of a plus the logarithm of b. For quotients, we have the quotient rule. The logarithm of a divided by b equals the logarithm of a minus the logarithm of b. A logarithmic spiral or growth spiral is a spiral curve for which the distance to its center point increases by a constant factor on every turn. Now let's take a look at the occurrence of logarithms in nature, where many examples of this can be found. For instance, the growth of mollusk shells or patterns of floret growth. Natural logarithms play an important role in growth and decay processes, such as bacterial culture growth or radioactive decay. An everyday example for many people is the decay of a beer head. The natural logarithm of the actual foam volume equals the natural logarithm of the initial volume minus k times the time variable, where k is a decay constant. The foam of an excellent beer should have a half-life of more than 110 seconds. Good beers are between 91 and 110 seconds and a half-life between 71 and 90 seconds is generally considered acceptable. Thank you for watching.